Good morning, or afternoon, or evening, or whatever it is for you. Welcome to the first lecture on number properties for the Euro GMAT quantitative review section. So today we're going to talk about just sort of the basics of number properties and some of the most important things that you come across on the GMAT exam. Here's a list of the things we're going to cover in this video. So first we're going to talk about integers and some of the basics, some of the basic vocabulary that you come across. Next, we're going to discuss primes. And primes are something that come up all the time on the exam, and also something that you may have seen a long time ago, not recently. So it's a really important topic to review. Next, we're going to talk about squares and cubes. These are a bunch of numbers that are really important to memorize. Next, factors and multiples. Once again, you've probably seen this before, thought about it before, maybe a long time ago, but we're going to talk about it potentially in a slightly different way from what you're used to. And then finally, we're going to talk about prime factors and divisibility. Now, along the way, we're going to be discussing a whole bunch of different what are called organizational tools. And you may have heard me talk about organizational tools before in the first video. Organizational tools are essentially frameworks for organizing common types of GMAT problems in a visual way on your paper. And it's important to, as you practice and as you encounter problems and as you do exercises and practice tests, it's important to develop a kind of toolkit of organizational tools. So we're gonna be looking at a few of these basic organizational tools as we go through the problems today. But the basic idea is that as you develop these organizational tools, they help you whenever you recognize that you have a problem in front of you that sort of follows a certain common type of GMAT problem. You already have a ready way of organizing the information in that problem, and that can save you valuable time on the exam. Okay, so let's go to our first topic. So the first topic, really quite simply, integers. Now this is something, of course, you've seen before if you've ever done a practice test or anything. Integers for the GMAT exam. So I'm just gonna make a little bit of a quick number line right here. Let's see if I can do this effectively. So yeah, so alright, so let's pretend that this is 0 in the middle. So what is an integer? Well, an integer is a whole number. Another way of looking at it is it has no decimal places. It has no decimal places. It's not a decimal number. It doesn't have a point. It's just a whole number. And if you think about the number line, we usually sort of notate little notches, and each of these notches here represents an integer. So this can be negative, and this is going to be positive up here. Alright, so a couple of important points to make about integers. Integers can, here, let me just move this down quickly. Integers can be both negative and positive. These are all integers. 0 is an integer. So let's always, sometimes we kind of forget that 0 is an integer, and this is an important thing to remember in the GMAT. Now, what I've drawn here is called a number line. This thing up here is called a number line. And this is actually one of our first, this is going to be our first organizational tool as we go through the GMAT. So a number line is our organizational tool number 1. Okay, well, let's talk a little bit more about some of the basics of integers right now. So first of all, an integer plus another integer will always equal an integer value. Same thing for subtraction. An integer minus another integer will always equal another integer. Same thing actually for multiplication. An integer times an integer will always equal another integer. The only time this doesn't hold true is that an integer divided by an integer doesn't always equal an integer. Okay, so let me spread that out a little bit. Okay, so those are our basic integer rules to remember. And there are two very important types of integers that we'll go into a little bit more detail on, and these are odds and evens, or evens and odds. Okay, so just to remind ourselves what we're talking about, let's go back to our number line at the beginning. So if I were to circle I'm going to just kind of circle the odd numbers here. So 3 is an odd number, 1 is an odd number, 1 is an odd number, 3 is an odd number, 5 is an odd number. So as you can see, odds and evens, they can be negative and positive. Important to note, 0 is actually an even number. We often forget this. So 0 is actually technically considered to be an even number. So let's talk a little bit about our odd and even rules right now. Give myself some space to work. So an odd, actually let's just start with even. So an even plus another even is always going to equal an even number. An even plus an odd number is always going to equal an odd number. And an odd number plus an odd number is always going to equal an even. Right? Okay, now let's think about multiplication. So an even times an even is always going to equal an even number. An even times an odd number is always going to equal an even number. And an odd number times another odd number is always going to equal an odd number. Now it's important to just think about this for a second. So first of all, with addition, right, we have a number of different ways we can get an even just by adding two evens together or by adding two odds together, right? So both of those can lead to an even. So when through addition, let's write this, through addition you can get an even by adding two evens together or two odds together. Okay, so that's an important point. Now if we think about multiplication, the important point to remember, so through multiplication, this is the way I like to put it, the only way to get an odd number, to get an odd, is by multiplying only odds. So in other words, there's only, if you know that you've multiplied two numbers and you've gotten an odd number as a result, even if you don't know what those two numbers are, two integers are, well, you know that they were both odd. They had to have been odd. There's no way of multiplying an even, then an odd, and odd, and odd, and ever getting anything aside from an even number. All right. Moving right along, let's talk about primes. Okay, so primes, this is something that pretty much everybody has seen before, probably a long time ago. It's not something that we have to deal with very often in everyday life. So let's just quickly remind ourselves of what the definition of a prime number is. So a prime number is an integer, or actually I should say a positive integer, that is only divisible by 1 and itself. It's a positive integer that is only divisible by 1 and itself. Now, this is definitely the definition that we learned in school, and it's a pretty useful definition in a lot of ways, and we're going to use it right now. But what we need to remember is that this is actually not the exact definition, right? I'm going to put these little squiggly equal signs here. It's not the exact definition of a prime number. It's one definition of a prime number that's often used, but it doesn't really explain everything about primes. And it certainly doesn't tell us necessarily why primes are considered so important. Okay, so the first thing that I want to do just quickly is list the first 10 prime numbers. The first 10 prime numbers right here so that you have them in one place. And this is a list that you really should commit to memory. So the first prime number, the smallest prime, is 2. The next one is 3, then 5, then 7, then 11, then 13, then 17, then 19. Now you might think to yourself, oh, 21, but 21 is actually not prime. It's 7 times 3. The next prime number is 23. If you think about it, 25, 27, both of those can be divided, and the next prime number is 29. Okay, so these are the first 10 prime numbers, and these are to memorize. Memorize these. It's really just a good idea to have them committed to memory because they come up so often on the exam, and it's just, you don't want to be sitting there on test day trying to scratch your head and think, is 19 a prime number? You just want to be really prepared on that. Obviously, this list continues forever. We could go on forever. In fact, they're discovering new gigantic prime numbers all the time. But for the GMAT purposes, the first 10 are really the only ones that you have to have in the back of your mind at all times. Okay, a couple important notes about primes that you'll notice from this list. Let me just minimize this a little bit. Oops. Okay, so 2 is the only even prime. Okay, that's the only even prime. All primes that are greater than 2 are odd. Next thing to notice is that 2 and 3 are the only consecutive primes. Primes. And consecutive primes, what do I mean by that? I mean that they're right next to each other. 2 and 3 are the only consecutive primes, the only primes that are absolutely right next to each other on the number line. And then finally, a good thing to remember is that 0 and 1 are not prime. And this is where it gets actually a little bit tricky, especially with the number 1, because if you think about it, number 1 does actually satisfy this definition up here. 1 is only divisible by 1, and so it's only divisible by itself and by 1. And so it seems like it would satisfy the definition that we've written up above. But there's actually a good reason that it doesn't satisfy that definition, and that's why we're going to clarify what the definition of a prime is later on in this lecture. But before we move on, I want to give ourselves a little bit of intuition about primes. I remember when I first encountered primes a long time ago, it was a little bit unclear to me why people cared so much about primes. I mean, there are a lot of types of numbers out there. There are a lot of interesting numbers. Why are people so fascinated by primes? What's so special about primes? All of this stuff, I didn't really get it when I first encountered them. And then I learned something that really kind of unlocked the puzzle, and that made me think of primes in a really new and interesting way. And I'm going to share that with you right now because it's really helpful for the intuition on what primes are and why they're kind of important. So if we go back to ancient Greece, in ancient Greece, there was a different way of looking at numbers. The Greeks didn't, I mean, they certainly had little symbols for um, the numbers 1 through 9, or 0 through 9, but they didn't really think of numbers in the same way as we do today. They instead thought of numbers as little dots. So let's say the number 12 would be 12 little dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's the number 12 for the Greeks. And they noticed that you could write the number 12 like this, right? You could also write the number 12 like this. 6, 7, 8, 9, 10, 11, 12, right? You could also write the number 12 like this. So, and if I surround this, it kind of forms a rectangle, and this one does also. So number 12 could be written in a couple of different ways. And if you think about this, this kind of represents 4 times 3, and this kind of represents 2 times 6. Right? So, and of course, you could just lay them out flat. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? And this would kind of represent 1 times 12. Okay, so these are all kind of rectangles. You could form these little dots in rectangles. All right, but then some numbers just didn't work out this way. So if you take the number 7, we could do 1, 2, 3, 4, 5, 6, and then 7. But this extra dot, we just have nowhere to put it so that it forms a rectangle. There's just nowhere we can put it. I mean, we could, maybe try 1, 2, 3, 4, 5, 6, 7, right? We can arrange these in different ways, but we can't make these dots form a rectangle. In fact, the only way to do that is to lay them out flat. 1, 2, 3, 4, 5, 6, 7, right? And then finally we have a rectangle, and that kind of represents 1 times 7. All right, so the way the Greeks kind of thought about this, the way the Greeks kind of defined what primes were, and the definition that I really I like a lot, because it helps me out. So Greeks define primes as numbers that cannot form a rectangle in the way that we've seen just a moment ago. So numbers that cannot form a rectangle. Okay, so that's kind of interesting. And so any number that can form a rectangle is not a prime. Any number that cannot form a rectangle, except for just sort of laying them out flat, is a prime number. All right, let's move on to the next topic. Okay, now we're going to talk about squares and cubes. Okay, so just first of all, quickly, a definition. This kind of ties into what we just saw. So squares, or otherwise known as perfect squares, actually I'll write that, perfect squares, so a perfect square is anytime you have any integer multiplied by itself. That's a perfect square. Move that over. Okay, Okay, so a perfect square is any integer multiplied by itself. And let's give ourselves a nice little list of perfect squares. So if you multiply an integer by itself, if that integer is negative, if you multiply it by another negative, you're going to get a positive. So all perfect squares are greater than -1. So actually the lowest perfect square is going to be 0. That's the smallest perfect square, and that makes sense because 0 times 0 equals 0. Oops, let me do this again. I kind of lost it. Oops, so we have 0. The next perfect square is 1, because 1 times 1, well, equals 1. Then we have 4, 2 times 2. Then we have 9, 3 times 3. Then we have 16, 4 times 4. Then we have 25, 5 times 5. 36, 6 times 6. 49, 7 times 7. 64, 8 times 8. 81, 9 times 9. 100, 10 times 10. And let's just go a little bit further. We have 121, which is 11 times 11. 144, which is 12 times 12. And a couple of others that are kind of good to know because they do come up a lot. And I'll write these down below. A couple of other perfect squares that you should have in the back of your mind. 15 times 15 equals 225. Very good perfect square to know. And 25 times 25 equals, do the math, 625. Okay, so these are the perfect squares that are really important to know for the GMAT exam. And once again, if you just kind of go back to that that kind of intuitive idea about a prime number being sort of an arrangement of little dots, well, each of these represent numbers where those dots could actually be arranged in a square. So let's do that right now. So for example, let's take, well, we won't do anything too crazy, but let's do the number 16, right? 16, well, we can do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and then we have, if I had drawn them more accurately, we would have a square, a complete square here. I didn't, but there you go. And so this kind of represents 4 on the side times 4 on the top, which I think is a really nice way of looking at it and thinking about it. All right, so the next thing, of course, is just perfect cubes. And I'm not going to spend too much time here, but perfect cubes are any integer multiplied by itself 3 times. Okay, and we're just going to give a really short list of perfect cubes. There aren't really that many that come up often on the GMAT, and so I personally don't think I think it's important not to over-memorize things, because then our brains get filled up with things that aren't really actually that helpful. But we'll give the first few perfect cubes. So it's important to note that a perfect cube can be both positive and negative, or sorry, it can be either positive or negative, right? Obviously it can't be both at the same time, because if we multiply a negative number by itself 3 times, we actually get a negative number. So the perfect cubes continue endlessly in both directions, in the negative side and in the positive side. So let's think about this for a second. 0 is a perfect cube. 0 times 0 times 0 equals 0. 1 is also a perfect cube, because 1 times 1 times 1 equals 1. 8 is a perfect cube. That's 2 times 2 times 2. Right? 27, that's 3 times 3 times 3. 64 is also a perfect cube. That's 4 times 4 times 4, and 125 is also a perfect cube. That's 5 times 5 times 5. And I think that that's a good list for us already. Now, in the negative direction, of course, we could just, continue this. So we have actually minus 1 is also a perfect cube, right? Minus 8 is also a perfect cube. Minus 27, also a perfect cube. Minus 64, also a perfect cube. And then minus 125 is also a perfect cube. And of course, these go endlessly in both directions. We could continue this forever. But for the GMAT, these are the ones that I really recommend memorizing. Okay, let's go down to the next topic. All right, the next topic, factors. And factors are, this comes up really quite often on the GMAT, and certainly something that you've seen before, but we're going to maybe talk about it in a slightly different way from what you might be used to. Okay, so the factors of a number, another word for the factors of a number are divisors. Let me write this. So you sometimes see the word divisor. Factors and divisors mean the same thing. And what do they mean? Well, any integer that divides evenly another integer, or I should say the integer that you started with. This will be clear in a second. The integer you start with. Okay, perhaps not the most clear definition. I'll give you that. But anyway, let's take a look at some examples, because usually with examples this makes a bit more sense. So let's start with a good number like 36. I want to start with 36. Okay, so 36. First of all, 1 is always a factor of every number. So we'll have 1, and 1 times 36. Okay, that gives us 36. Okay, 2 actually is another factor of 36. 2 times 18 equals 36. 3 is another factor of 36. 3 times 12 gives us 36. 4, another factor. 4 times, in this case, 9. Whoops, 9. And then finally at the bottom we have 6 times 6, right? Also gives us 36. Okay. And what you can do to find the factors of a number is make a little bit of a chart like this. And so this is called a factor chart. I'll write that. And this is our organizational tool, OT number 2, from this video. OT number 2. It's a factor chart. And the way it works is that on the left side of the chart, you kind of increase, you go up from 1. And on the right side, you just kind of add whatever, or multiply whatever number gives you the number up here. So when I started with 1, and I said, well, 1 times 36 gives us 36. Great. Then I went 1 up here and said, okay, 2, well, 2 times what? 2 is a factor, so 2 times 18 gives us 36. And I continue that until the numbers meet at the bottom, or I can't find any others. So I continue that until the numbers kind of cross at the bottom, and then I've found all of the factors. So factors of 36, let's just quickly write them down. So factors of 36, we have 1. Actually, let me do this in text. I don't want to make things so messy. So factors of 36, we have 1. If I were to list them in increasing order, 2, 3, 4, 6, 9, 12, 18, and 36. Great, so, and that's the complete set of factors of 36. All right, we're going to do another one, another factor chart, because it's so fun. Let's do, I don't know, 56. Let's do 56. Kind of chose that randomly. Okay, so as usual, we're going to start with 1. And 1 times 56 gives us 56. Okay, then we'll increase 1 here. So 2 times what gives us 56? Well, it's actually 28. Think about it. Okay, 3. 3 is not a factor of 56. It doesn't divide it evenly. But 4 does. So we have 4 times 14. Okay, and then 5 doesn't work, 6 doesn't work, but 7 does. 7 times 8. And then if I can continue here, if I were to continue on this side right here, well, they would actually cross, so I know I've reached the end. And so I've got all of the factors of 56 in one nice place. And let's just list them right here. So 1, 2, 4, 7, 8, 14, 28, and 56 itself. All right, let's do one more, just because, you know, it's kind of fun, right? Let's see, which one should we go with? Let's go with 27. I'll go with 27. Okay, so we'll start on this side. So 1 times 27. Great. 2, no, doesn't go into 27. 3 does, though. It's 3 times 9. Okay, 4, no. 5, nope. 6, nope. 7, nope. 8, doesn't work. 9 works again, so if we were to put 9, but then we'd actually be crossing, so we don't need to add that. And so we have all of the factors of 27. So let's write them over here. So 27, the factors are 1, 3, 9, and 27. Okay, so let's think about the numbers that we just listed right now. So the first number was 36, and as we saw, it had 9 factors. 36 had 9 factors. The next number that we saw was 56, and as we saw, 56 has 8 factors. And then we saw 27, and 27 has 4 factors. You might sit there and think about this for a moment, but what's special about 36 that 36 has an odd number of factors, right? So 9 is odd. 56, of course, has an even number of factors, and 27 has an even number of factors, even though it's an odd number that we started with. 27 is odd. You might think about, well, what's special about 36? And you might guess it, but it's an important rule to know, which is that only perfect squares have odd numbers of factors. So the only way that you can have an odd number of factors is if it's a perfect square, is if the number that you started with is a perfect square. That's an important rule to know. And if you think about it, well, why is that? Well, it's because the only way that you're going to have an odd number, because we're kind of, as we kind of make this chart here, we make 2 columns, right? We make 2 columns. So each of these factors is going to come in a pair. We have a pair here, a pair here, a pair here, and a pair here. So the only way you can have an odd number of factors is when one of those pairs is actually the same number down here, right? 6 and 6. So when one of those pairs becomes the same number, Well, that by definition means that it's a perfect square. It's an integer times itself. That's kind of interesting and certainly something that's important to reflect on for future questions that you'll see on the GMAT exam. Okay, next let's talk about multiples. Multiples and multiples of a number. Let's just give the definition. A multiple of a number is just any number times any integer. So let's say that n, any number n times any integer equals a multiple of n. N times any integer. Let me make that look less like an x. Okay, n times any integer equals a multiple of n. Okay, well, let's give ourselves an example. Let's take the number 12. So let's write the number 12 right here. So if we just count by 12s, we'll get all the multiples of 12, or not all of them, but we'll get a bunch of multiples of 12. So 12 is a multiple of itself, because it's 12 times 1. 24 is a multiple of 12, 12 times 2, right? 36, 48, 60, 72, right? 84, etc., etc., etc. So we could continue this list endlessly. All of these would be multiples of 12. Now, technically, according to the definition, 0 is a multiple of every number. Of every integer, rather, I should say. Should be more careful. 0 is a multiple of every integer. And, of course, multiples, let me not write that in big letters, multiples can be negative. However, for most GMAT problems will only deal with positive multiples. It's usually clearly stated in the problem if they're looking for positive multiples, that it'll be clearly stated somewhere in the problem. So positive multiples. Okay, so that's important right there. Now I want to think a little bit about what multiples are and what they mean. And to do this, and we're going to think about them in a slightly different way, and to do this I'm going to come back to the organizational tool that we saw right at the beginning, which is the number line. Okay, so let me just fill in the number line a little bit here. So the number line goes endlessly in both directions. And let's say that we have, well, let's do 12, right? 12, and we do a bunch of notches, and then we get to the next multiple of 12, which is 24. Do a bunch of notches, and then we get to the next multiple of 12, which is 36. We do a bunch of notches, get to the next one, 48. We do a bunch of notches, and we get to the next one, which is 60. So first of all, a good way of visualizing what multiples are, I like to think of them on the number line. They're kind of like hopping along. So we just hop by a fixed amount from one to the other, to the next one, to the next one, and these are all the multiples of 12. And of course, the distance that we hop each time is going to be 12. So we plus 12, plus 12, plus 12, and plus 12. Right? So these are all the multiples of 12. And so what is so interesting about this? Let's think about that for a second. What's so interesting? Well, each time when we're between multiples, right, like here, or here, right, or here, right, when we're between these, in each of these cases, all of the numbers in between, right, we have to remember, none of them, so let me make this smaller, none of the numbers in between are multiples of 12. None of the numbers in between are multiples of 12. Right? And this is kind of important because what we need to remember is that multiples are related to factors, and so each of these multiples of 12, 24, 36, 48, and 60 has a factor. One of its factors is 12. And if we want to think about what numbers might have factors of 12, well, they're going to come in this regular pattern. All the numbers that have factors of 12, that have 12 as a factor, are going to come in this regular pattern. They're kind of going to hop along the number line, kind of like this. So it's a nice little way of thinking about it. Okay, let's go now to kind of the final point that we're going to make in this video, and of course this is something that we're going to continue in a future video when things get a lot more complicated than they have been so far. So prime factors. Now this is something that probably many of you haven't actually seen before, just because it's not something that we necessarily see in a normal math class. I mean, some people do, but it's not necessarily part of the normal math curriculum, even though it should be, because frankly prime factors, in terms of one of the most important things that just in life that you'll learn on the GMAT, in preparing for the GMAT, I'd say that prime factors is really right up there, and really one of the most fascinating things too. So if you don't get into prime factors just from the GMAT, I don't know what's wrong with you. But here we go. So prime factors, well, first of all, the definition, really simple. You can probably figure it out just by the name. So prime factors are the factors of a number that are prime. Okay, but once again, just definitions don't really help us because they're confusing and not clear and stuff like that. So let's give ourselves an example, and we're actually gonna let's use a number. Let's use an example number. Let's use 90. We're gonna use the number 90. Okay, so we can start by putting the number 90 up here, and then we're gonna make two little lines with arrows. And let's think, what two numbers can multiply to give us 90? Well, 9 times 10 gives us 90. Great. Let's do two little arrows from the number 9 and two little arrows from the number 10. What two numbers can multiply to give us 9? Well, 3 times 3. Okay, and now 3 is a prime, so I'm actually going to circle that. Circle this one. What two numbers multiply to give us 10? Well, 2 and 5, and 2 is a prime and 5 is a prime, so I'm going to circle those as well. And so I can rewrite 90 as 3 times 3 times 2 times 5, right? And actually this is what we call, let me write this in text, right? We call this, put this down a little bit, we call this the prime, oops, hit the wrong button there. So the prime factorization of 90. This is the prime factorization of 90. Okay, so the prime factorization of 90, and what we did here, what we did down here, this whole thing is actually our another organizational tool. I like to call it the, let me write this in text once again. This is called the, move this down, okay, the prime factor tree diagram, or just a prime factor tree. And this is our final organizational tool of today, or of this lecture, so organizational tool number 3. Right? Okay, let's do that. Let's do that again with another example, just to make sure that we've got it. Maybe a couple more examples. So let's do, I don't know, the number 120. That's one that has a lot. It's got a lot going on with it. So number 120. All right, so first I want to think of two things that multiply to give me 120. Well, 2 times 60. That's good, and I'll circle 2 because it's prime. Okay, now I need to think of two things that multiply to give me 60. Well, 6 times 10. Now neither of those are prime, so I can't circle them, but 6, then I'll give two little arrows. 6 is 2 times 3. Circle those. And 10 is 2 times 5. I'll circle each of those. Okay. And so 120 is 2 times 2 times 2 times 3 times 5. And another way of writing that is 2 to the power of 3 times 3 times 5. And so this is the prime factorization of 120. And if we were to list, so the prime factorization, let's say the prime factorization of 120, right? That's what we've got right up here. So the prime factorization of 120 is this thing right here. And it's important to note that the prime factorization is a little bit different from just the different prime factors of 120. If we think of the different prime factors of 120, well, here we've got 2, 3, and 5. So we would say that 120 has 3 different prime factors, even though there are, if you look up here, there are 5 numbers in its prime factorization. There are 3 2s, 1 3, and 1 5. So when we're considering the different prime factors of 120, we only take each of the prime factors once. Okay, let's do this one more time. We're going to do this again. So let's take another number. Let's take a bigger number. Let's do something crazy. Let's do 100. I'm going to do 168. Okay. Now that should so 168. Probably not obvious which two numbers multiply to 168, but at least I know if I just look at 8, I know that it's even. So I know that we can do 2 times something, and I'll circle 2. And if I just kind of think about this a little bit, 168, okay, so it's going to be 2 times 84. 2 times 84. And maybe I'll just quickly write that up here. I often just like to check these things. So 2 times 4, that's 8. 2 times 8 is 16. Okay, great. Cool. So it's 84. And now 84, let's see, well, it's even, so I can certainly pull out a 2. So that's going to be 2 times 42. Okay, yeah, that makes sense. 2 times 42. 42, running out of space down here, is going to be 2 times 21. Okay, and then 21 can get really small down here. Now that's something I recognize. That's going to be 3 times 7. 3 times 7. All right, so let's see. Let's write this in text. So then the prime factorization is going to be 2 times 2 times 2 times 3 times 7, right? The prime factors, or I should say the different prime factors of 168 are simply 2, 3, and 7. Okay. Great. Well, so hopefully this has been enlightening, and hopefully this lecture has kind of made you think about a few things in a different way. I just want to quickly remind ourselves some of the stuff that we talked about. Specifically, what I want to just go over are the organizational tools that we have covered and that should be added to your toolkit. So, number one, the first organizational tool was the number line. And we use it in a couple of different ways today. Frankly, I use the number line all the time, and a lot of people kind of, when they're working on the GMAT, they think that because it's a test to get into MBA programs, that the math and the tools that you use should be complicated. But actually, the simpler the tool, the more reliable and the better it is for the GMAT exam, and the more efficient as well. So the number line is something that I frankly like to use all the time. The second one we saw was a factor chart. Right? That's where we listed the factors of a number in two columns until the two columns met. And the third one that we saw was the prime factor tree. And that's where we kind of made a tree to find the prime factors of a number. So these are the three organizational tools to add to your toolkit, and of course, as you go through the lectures and as you go through the videos and as you go through exercises and all sorts of things, we're going to be talking about lots and lots of organizational tools together, and you'll probably find a few organizational tools on your own that work for you. So thanks for watching this video. The next video, Number Properties 2, is going to be picking up where we left off, but really talking about some more advanced material. This has been really kind of just an introduction to some of the number properties concepts that we need for the GMAT. It gets far more advanced in the next video, so stay tuned. Before you get to the next video, though, I do have 20 practice questions that you should go through, and each of these practice questions, of course, comes along with a video explanation. So basically the way it works is you see the practice problem, you try to work it out on your own. If you get it wrong, or if you have particular difficulty with it, you should click on the video explanation before moving on to the next practice problem, because they're kind of arranged in increasing order of difficulty like that. Anyway, thanks a lot for watching, and I'll see you for the next lecture.